So now I would like to introduce our keynote speaker, Crachad Laing. He is the head of digital literacy at King's College in Nassau, Bahamas. Raise your hand if you happened to be here last year and heard Crachad's talk. All right, we have Corey. Yay. Corey, you got to make more noise. If you weren't here last year, this is the reason why we invited Crachad back. He's an incredible educator. He's an engineer. He's a software designer. He's been doing this work really thoughtfully with children K through 12. And it's really rare to find someone who is in the classroom, who's thinking about innovation, thinking about creativity, but also has this training as an engineer, but this heart and mind as a teacher. And so we wanted to bring him back today with an impossible task. I call it the design challenge of his career, to try to take all of the important things that he has learned over the years and sum them up for us in 20 minutes. And so that is what we are going to have Crachad do right now. So Crachad, welcome. Thank you so much. And we look forward to your conversation.
All righty. Good morning, everybody. As Deetra introduced, my name is Crachad Laing, and I'm here to talk about creativity and innovation in the classroom. As she described, I'm an engineer by degree, teacher by profession and practice, and I'm extremely passionate about developing the next generation of thinkers and problem solvers. And so on my first slide here, we could see, one of my beliefs is that innovation in education isn't about new tools, it's about new thinking. And as we all can probably feel and sense, there's a lot of new tools that need new ways of thinking in our current educational environment and landscape. So a little bit more about me. As Deetra said again, I'm head of EdTech at King's College School in the Bahamas. That role involves me being able to support students, faculty, and curriculum in terms of integrating engineering and technology practices into the classroom, as well as supporting all the technology that keeps our school afloat. I'm a founder. I have a nonprofit organization called Happy STEM, where we host engineering and technology summer camps, workshops, after-school programs, and the such for underserved communities. And then finally, I'm an advocate for engineering and technology learning. I believe that exposure is the key component to being able to onboard into these sorts of spaces, to find identity in these spaces, and to feel comfortable pursuing them in the long run. And so I'm extremely passionate about bringing opportunities for that first spark and exposure to young people. Technology is a tool, not the end goal. My philosophy is that technology should do three things in an educational environment. It should enhance our thinking. It shouldn't supplement our thinking, but it should allow students, professionals to be able to think more effectively and efficiently, being able to stop road gaps and get second opinions and ideas on what it is that you're already working on. We should foster creative agency, meaning that the creativity still comes first. The original thoughts still come first. The end goal and output from the perspective of the student still comes first. And it's very important that as we use these tools, we understand that. And finally, being able to blend or create a bridge between theory and practice. To me, that's been one of the more advantageous parts of technology integration, is it allows for, again, seamless representation of ideas. It allows for diverse opportunities to showcase understanding and knowledge, and again, allows for students to gain a certain level of digital literacy proficiency. If we take a look at the picture above this slide, actually, that was from our pre-service teacher workshop yesterday, where these are two pre-service teachers who have never coded anything in their life, building a website yesterday. It was a 30-minute workshop, and they got through a lot, but we'll talk about that a little bit more at the end of the slides. And so last year, my presentation was a lot more of a case study. We went into best practices, pedagogy, all the things that relate to teaching and learning with technology and through technology. Today is more of a showcase. For me, at the end of this presentation, if at least one of you, leaves a little bit more inspired, right? A little bit more confident and eager to be able to bring technology into your classrooms, to allow your students to be creative, with the use of technological tools, then that would be a big win for me. And so my showcase starts with STEM Saturdays, a Happy STEM program, as I described my nonprofit organization. And STEM Saturdays is where I see students weekly. Me and my team, we meet students weekly. They come from all different schools on my island, and it's 6th through 12th grade right now, and we work on engineering and technology projects. This is a showcase of a long-term project that I have Ali up on the screen working on. He created a Christmas ornament out of aluminum alloy and programmed LED lights in it so that it lights up. And then it says Merry Christmas. I'll zoom in on some of those slides in just a second. But if we take a look, we could see some of Ali's feedback. And so through the learning management system that I'll talk about a little bit at the end, we're able to have students, again, not just utilize technology, not just apply STEM skills, but connect it to what they already know and what they're already used to doing. And so we could see here that on October 14th, Ali started with just learning how circuits run, how different terminals on an LED. And this is his direct feedback, his wording. And then by December 17th, we did a 3D model and design of his actual Christmas ornament. And so we could see here where, he had Merry Christmas from the Bahamas. And the cool part about this project was it brought in a couple different components. It was a project-based design, and so students started with their own original ideas and went from sketching drafts of these designs into manufacturable designs. It was a global manufacturing process. And so for us in the Bahamas, we're pretty limited in terms of resources, everything from raw material to equipment and tools to also expertise, right? And so we were able to connect with a company in China through email and send them our designs and have them manufacture them. If we note at the bottom here too, Ali also included the cost of one board. And so we went from this learning environment of understanding circuits like you would in most science classes in middle school to now applying that skill through computer-aided design to now seeing how this goes further into entrepreneurship by understanding this global manufacturing process and how much certain things cost. And to me, this is an example of innovation in education. As we look to the future, I find that it's very important that we not just have our students understand what they should know, but it's of dire importance, actually, that they know how to apply it. Where I used to say this all the time, we live in a world where at the touch of my finger, I can have and know anything, right? On my phone, I can look up anything, but now it's almost 10x or grown exponentially with generative AI and large language models. And so it's not that what you know has lost value, but how you apply what you know has definitely gained importance, right? It's kind of the only way to validate and show true learning. Later on in the same year, I did a 3D printing and entrepreneurship workshop with a group of underserved kids. These kids all go to local public schools. They're from pretty impoverished neighborhoods, but all very excited, passionate engineering and technology students. And so we went from these kids not understand, most of them haven't used a computer before, most of them hadn't designed anything on a computer, most of them didn't know what a 3D printer or a laser cutter was, and so I spent the week with them onboarding them into these processes. And so we created some student entrepreneurs, we talked about sustainable manufacturing, and most importantly, we talked about ways in which we could use this technology to innovate in their communities. When I first went to the site that this program was at, it was kind of in the middle of nowhere, right? Not necessarily the nicest part of town, but I got there about 30 minutes early, and about maybe 15 minutes before the session, I started seeing loads of kids just walking in. They're coming from literally the bushes and the weeds, walking from their house, to this, workshop location. And I just thought that that was beautiful, right? It was one of those moments where, oh, I actually don't need a big fancy space, or I don't need a ton of sophisticated resources. I actually just need to create the environment where they're allowed to come and express ideas and, learn new things. And if we could see, this was around our country's independence time. And so again, being able to consider different aspects of relevance, and obviously independence was very relevant at the time, and so our 3D printing project was themed around, independence designs. At the end of the summer, one of the things that I've been particularly thinking about and designing lessons and curriculum and even getting into the ethics of is how do we introduce students to agentic or AI agent tools. There's a big lack of guardrails and safeguarding and policy as it pertains to students interacting with these tools. A lot of the intricacies of what these models are saying back to humans and where this data is housed and how it's being used is still a little bit messy. And so for me, knowing that, hey, these tools are extremely powerful, the game in terms of software engineering and development has actually completely changed, and I need these students to access these tools as soon as possible, to start learning these processes and get comfortable with developing skills in this direction. And so we did an agentic coding workshop where I had students consider a website or application that they wanted to build, and they spent about 4 or 5 hours over the first 2 days of that workshop learning about software systems, how software connects on a pretty low level as well, right? Understanding that this is a website, and this website is connected to a database. And so when we fill out this form, that information is stored in this database. Talking about front end and back end, and really getting to have them understand how software works, right? Without, again, these are students that have no experience with coding. So they don't understand programming languages or anything along those lines. But to me, the important thing was to get them thinking systemically and thinking in terms of how components connect together. And this is a productive train of thought for software, but it's just a productive train of thought for problem solving generally. And so I, again, use these sorts of practices across different subject areas as well. And so what the students got to do through this tool was they designed diagrams and they made sketches and descriptions of their website or game or app that they were making. And then through human language, they were able to speak with an AI agent that then developed these tools for them. And so if we zoom in here, it may be a little bit blurry, but this was a screenshot of one of the students. It says game over, because he made a jumper game similar to Donkey Kong. And if we look at the left side of the screen, this is all human language. And so Akil actually told me, Akil is one of my former students who was working the workshop with me yesterday, and who was here. Akil, wave to the people. Awesome, Akil's awesome. And he told this to me, and it was pretty powerful. He said, Mr. C, natural language is the new programming language. It was once a big barrier to innovation, because to innovate through the best tools for innovation, which are computers, you needed a pretty intense skill set. You needed to spend years and years understanding how to program and learning different programming languages and libraries and things and such, connecting them. But agentic tools have eliminated that barrier. And so classical training and understanding of programming languages is still very important, but it's no longer, again, a barrier or excuse to creativity and production. It was an interesting stat from Y Combinator earlier in this year. Y Combinator is an organization that funds innovative projects, and it was an interesting stat where 95% of the code for their products in the incoming class of entrepreneurs at the beginning of the year, 95% of the code for 90% of the products was AI generated. And I thought that that was a huge insight, because very clearly we could see that how we do things it's shifting. And so the world that, again, we're preparing these students for in the future, we must do things slightly different, well, a lot different actually, to be able to get them ready for that, right? Because it's new for everybody. It's definitely new for them. And the best thing we can do is equip them with what these practices look like and feel like. And so I'm going to stay on this slide, actually, because I do want to talk about coding as agency, not automation. And this slide talks about coding in this application, but what I'm really talking about is the use of generative AI tools. Again, we want to use them for agency, not automation. We don't want these things to complete tasks for us thoroughly, but we want them to empower us to make better decisions and have better products and outcomes at the end. For students, this platform, this engagement, normally, if I want a student to build a website, we probably need at least a semester of web development, where that's not fun. Sitting down, sifting through lines of code, getting stuck, getting errors and bugs, it's a little bit frustrating for students, particularly young students. And so with the elimination of that coding bridge, we were able to express identity utilizing code. And so I had some students that made Candy Crush style games. I have some students that made websites for global issues that they were really, really passionate about. I had some students make games for their favorite sports game and things of the such. But all in all, it allowed them to see their identity in engineering and technology practices. It wasn't a barrier of, I find this coding stuff very complicated and I can't do this. It was, oh, this coding is very powerful, it's awesome, it allows me to be creative. It gave them problem-solving power. And so one thing I quickly noticed was that the vocabulary and the technical terminology that we were able to use almost immediately was pretty new for me. Normally, it would take a year, a full school year and semester of lots of different types of exposure and lots of practice to get to the point where we're speaking in programming terms, but again, me and my groups of middle school students were interacting like software engineers. And again, all due to the power that the lack of these constraints through learning to code brings with AI coding. And computational thinking. At the end of the day, again, it's agency, not automation. And so students still have to think very critically. They have to think very logically. Things still don't work. Things still break. And so they still interact with this iterative back and forth process of trial and error while being able to still have the opportunity to overcome those hurdles. We get stuck for a little bit, but we're never stopped. Up here on this picture, this was a screenshot from our learning management system where, just to showcase a little bit, it shows the code, or actual HTML and JavaScript code, in one panel, while showcasing a preview of the actual website in the next panel. And so these clips were from our workshop yesterday. I'd be remiss if I didn't take the opportunity to include these in these slides because it was pretty powerful. We took pre-service teachers that didn't have a lot of experience or exposure to technology in the classroom, and we worked them through what this could look like. And so if we take a look at this first video, this was a block coding activity. These teachers were tasked with creating an algorithm that represented the digestive system in biology. So it was really a biology class where we're using code and robotics as the tool of representing our understanding. And they're working through. But what I want to highlight here, look at this engagement. These are teachers. As they're sitting through, watching this robot ball go from point A to point B, let's look at the end. That's what we want to see. That's the win. Learning is such a complex neurological process. The best neuroscientists in the world can't tell us how we remembered what we had for dinner last night. And so being able to look for the learning in these sorts of tangible ways that aren't necessarily right or wrong answers, but it's good positive outcomes and high engagement is what I really look for in my classroom. If we can get to the end goal, regardless of how we got there, how much iterations it took, and if we can still remain positive and excited throughout that, then to me, that's how learning takes place and what learning looks like. If we take a look at the next video, this one's a bit short, but this was the section of teachers that were using the Sora Learning Management System to build their websites. And I'm going to pause right here, whereas we can see it might be a little bit blurry, but how the learning management system works is, for me, one of the issues with teaching kids to code is that they want to do certain things, but those things are a little bit outside of the scope of their understanding at the time. And so it's almost like I wouldn't want to take you into calculus content when there's a missing algebra foundation. We can explore and look at some of this calculus content, but it would make a lot more sense if we gained a solid proficiency with algebra first. And with Sora, with coding, it's similar. I don't necessarily want to get into building a website unless I have an understanding of web development structure. But through agentic tools like Sora, we're able to turn these into learning opportunities. And so as the student's building their website, how it works is they will prompt with what they want to happen. I want a background for my website that is blue. And the learning management system delivers it in the form of a task, where it walks the student through which files they need to access, what they need to look for in their code, and what changes they need to make. And so it gives us an opportunity to have students learn through their creation. And to me, that's, again, one of the more powerful forms of learning, is being able to learn while doing. If we look up top at this top picture, there's a collaborative component here. And so once again, showcasing how technology can bridge some of these gaps and make us so much more efficient, effective, and engaging in teaching and learning. These two individuals are working on the same website project from different devices. And so they're able to collaborate, discuss, talk with each other, and create, once again, an environment that fosters teamwork, that forces you to take on the ideas and ask questions to the next person. And so once again, the focus is very much coding and learning coding, but through these sorts of activities, there's so much of real-world application, intangible skills that we do develop as well through an innovative classroom. if we remember or recall back to this first task, this was a biology class. We talked about the digestive system. They learned about the routes and paths of food. But again, they used code to represent that idea or understanding. And to me, that's what technology is. It's a tool that helps us represent our ideas, that helps us communicate with other individuals, and that helps us solve problems. Technology is never really the point. I made this analogy to Dietra a couple days ago, where I talked about our cell phones, for instance. The point of a cell phone isn't that I have a cool phone or that what my phone is. It's, we only use our phones when we need them to complete a specific function or task. And so for me to communicate with other human beings, for me to capture specific moments. And so these are the main focuses. I don't take out my phone to just admire it and be like, oh, hey, look at this cool thing. You take out your phone when it's time to use it. And I think that that's what the perspective we should take for technology across the board. Because if we look at how technology is integrated in everyday life, again, it's not the point. There is so much technology on this table right now. Technology is actually, I wouldn't be able to project my voice this far and talk to this full room. I wouldn't be able to show visuals to everybody. So technology is a big component to how we do what we do. But at the end of the day, the point is our interaction. Without these slides, without this microphone, we would still accomplish the same task. Technology just makes it more easy and efficient to, again, represent ideas and communicate. And so as you're in your classrooms, looking at it through that sort of lens is pretty critical, if you ask me. Because at the end of the day, our students will be challenged in environments where they're going to have to apply their knowledge, they're going to have to utilize and integrate technology, they're going to have to quickly learn and onboard to new processes, and schools should resemble that, quite a bit. And finally, for me, an innovative classroom really bridges the gap from theory to practice. At the end of the day, this is a fundamental component. We want students to understand the content as it relates to a particular subject area, but once again, we want them to be able to apply this to that subject area as well as other subject areas. No subject or theme or topic lives in a silo, right? It's kind of hard to talk about politics without talking about economics. It's hard to talk about economics without talking about technology. It's hard to talk about technology without talking about geography, right? And the rocks that make the chips that we use. And so it's all so integrated and connected that our educational environment should really resemble the same thing. And so as I say, from theory to practice, I just had some points where, for me, I balance both in my classroom environment. And so being able to bridge that gap is actually an important component for me. And so when I think about the theory of what it is that I'm getting ready to deliver, I consider, academic models, curricular standards, and traditional instruction. How am I going to deliver this? What, are we measuring this up against? And, what sorts of different structures can we use to, implement this? Whereas in practice, it's a lot less structured, right? We're talking about experiential projects that could take all sorts of pivots and turns. We don't necessarily know what the next step may be. We're talking about implementing, business and real-world applications. And, finally, we're really talking about creativity and representation. And so everybody's work, should look particularly different. I'll end with this slide, or with this quote, because this is a big one for me as I talk to teachers of different subjects in my school and in my country, is how can we make every subject do what it teaches? And so in biology class, how can we make us do the digestive system processes and not just teach the digestive system processes? In literature class, how can we, or in history class, how can we, get more intimate and in touch with, the varying, the past times of, our interactions as human beings, right? And so for me, it's more about getting closer to, what it is that the actual interaction is about, as opposed to us just utilizing these practices and features as, once again, just novel, tools. And so I'll end there. This QR code at the bottom, as I talked about Sora Learning Management System, is for anybody that might be interested in implementing in your classroom. Akil and I are going to be making this available to people because, again, as we saw yesterday, as I saw all summer, very powerful tool to bridge the gap. And there aren't very many of them out there. And so that'll wrap it up for me. I think I'm good. Yeah. Thank you guys so much for listening. I hope that this was beneficial in some way.
So I wanted to see if any folks in the audience have questions for Crachad before we get ready to break. All right, and I'll give you the mic as well.
This is kind of a technical question. What CAD software do you use with students for the 3D printing?
And so I have a progression where my students start with Tinkercad,
Okay.
just basic shape manipulation, and then they move into a platform called Shaper 3D, which allows for more constraints and complex designs, but still basic shape manipulation. And ultimately, I work towards them getting a Autodesk Fusion 360 associate certification upon leaving the program in 12th grade. Of course.
Other questions?
Hi. What was the biggest hurdle you had to overcome? Whether it was a mindset of the students, whether it was a logistical, resource, but what was like the biggest hurdle you had to overcome, and how did you do that?
And you're talking about in programs generally, right? And being able to deliver these programs, right? It's always resources, honestly, and resources in the form of equipment and tools, but also, human capital, volunteers, instructors. There's more kids that are interested and need this sort of work than there are people that are delivering it, particularly where I'm from. And so those have been some of the major hurdles. But at the same time, some of the major opportunities. Some at times when I haven't had the resources or materials that we need, we still went on and actually ended up utilizing other resources to accomplish the same task, which honestly created a better outcome from a learning perspective. And then even in terms of the human capital, that's how the learning management system SORA was born. Having rooms of 40 and 50 kids with just one me, you have 35 hands that are up at any point in time. Having a agentic tool that allows for assistance in that regard, something that kids can reliably ask questions and troubleshoot with, allows for me to have much, much bigger ratios while maintaining the same personalization and efficiency to outcomes as I would if I had more instructors. And so those was definitely, it's always resources in the form of people and tools, because the equipment's expensive, right? But again, it does create an opportunity for us to think creatively, right? Understanding that the outcome is not related to the tool. If I don't have a Sparrow robot, but I want my kids to think computationally and I want to challenge their ability to think logically and create sequence and structure, there are other ways to being able to do that. That answered it.
Hi. So your example with using kind of coding and robotics to learn about the digestive system is really cool and interesting. I guess I just wondered, do you ever run into the problem where students are doing something like that and what they end up remembering is the coding and the robotics because that's cool, and they actually kind of forget or overlook the science learning outcomes?
For sure. That was actually one of my biggest pet peeves at the beginning of my career and doing all of this was that, honestly, the kids thought my class was too fun. It was like playtime, not learning time. And so it's almost like the learning would happen for some students on accident, while others just came in and they had a good time. And so for me, if we look back at this slide, reflections actually cleaned all that up, making a forced opportunity for them to discuss what they did in relation to the curriculum and objectives of the day. And so these are actually extensive reflections. A lot of the time for my younger groups, because I teach primary groups as well, those will just be checkboxes. Did I hit the objectives for today? And if not, how many did I miss? So that they at least reflect on, I used 2 characters in my Scratch design. I implemented 1 loop in my Scratch design, but I forgot to do a conditional statement, right? And so it still makes them aware of these things, reflects as it pertains to the actual assignment or task that they complete. And that, honestly, that simple task cleaned everything up. Sometimes I even do it in the form of a survey. I find that slowing it down, forcing them to, write or type, as opposed to just articulating to me, what has just happened, super effective techniques there. So I do hope that helps.
Any other questions? All right, well, thank you, Crachad.
Thank you.
Crachad
Thank
will
you.
be around.